So now we're going to install the wiring loom. I'll see you in the barn. So far we installed the cable to the contact switch or the ignition switch. We've checked position number 1, so we have power going to the fuse box once we place it in the contact position. And if we turn it a bit further, then we actually kick in the starter motor, as you have seen. So now we need to have a closer look at the fuse box, because we also have some additional cables there which are going to feed the light switch. So we've got mains power coming in to the ignition key. We have an output, which is the green cable, which is going to the first position onto the fuse box right here. And this is 12 volts, and it's only there when the contact key is turned to ignition. And this is going to feed through the fuse here all the gauges and the dials and the warning lights on these wires here. The green one and actually the purple black one. That's what is going to be used for that, and you'll see that in a few minutes. I wasn't sure about the green cables, what they were, but then again I did buzz it out with my ohm meter and I found that was exactly the feed for all the warning lights and the gauges. The second big brown cable, which was this one right here, has always 12 volts. This is coming straight from the battery. We're feeding it through the fuse, and this we're going to use for the light switches. Now this brown cable, I did buzz it out and I found out that it was actually this cable right here. If you look on the cabling diagram, you can see that this cable here on the loom is actually going to the main light switch. And we have 4 cables on it. The big brown one that I just showed you, that's one of them, and that's the feed in. So that's the 12 volts. It's going to the central position of the switch, of the light switch. And then the output is actually a main beam, a dip light, and a side light. Now I don't have a side light, and the side light is a white, red or brownish tinted cable. The dip is blue, brown, and then the main beam is actually blue and white. So now it's just a matter of identifying it on the switch, which positions those are. And this is the light switch. It's a 3-position switch. We can rotate between off, dim lights and high beams, and I buzzed it out to find out exactly which contacts are what. So I found out that the middle one right here was actually the input, the plus 12 volts coming from my fuse box. Then I had the blue and white cable, which is my high beam, connected to that spade over there, and then the other one, which is my dim light, is over here. I did not connect the white red cable, this one right here, because that one is for side lights and I don't have side lights. So if you need to figure out on how your light switch is working, well, then you need to buzz it out with an ohm meter. And if you don't have an ohm meter, you can do it in a different way, and I'm just going to show you that. But you will have to find, first of all, a common input, and that typically is a longer spade with multiple connectors on it. So let's have a look if this switch is now going to work or not. So I placed my voltmeter on 20 volts DC. I'm going to use one probe to the ground, and the other probe I will actually measure on my fuse box. Now here I measured 12 volts. This is the steady voltage that I always get from my battery, which is now going to my light switch, and I marked it lights. It's always handy to mark things. The other one is my ignition switch position, and you can see this is 12 volts as well, because I most likely have the contact on. Let me turn that off. Yeah, it was on, and now I have no voltage there. So let's now have a look right here on this cable, which is actually going to my light switch. The plus 12 volts on the light switch is going to the center point there, and you can see I have 12 volts. The output is either going to my dim lights or it's actually going to my high beams. And for the moment there is nothing, because the switch is in its 0 position. So I'm going to try to turn the switch while we are measuring. So first of all, I'm going to try the dim lights, and let's see. Now I turned on the dim lights, so that must be which connection? That's this connection right away. And the cable for that is blue and black. So that should be my dim light. My high beam is not connected. You can see 0. So if I measure 0 volts, if I turn it one more position, then I should measure, oops, in the other direction. Then I should have my 12 volts turning on. In fact, you might see some light burning because I have it actually hooked up to be tested. All right. If you have no voltmeter, you can also use a light bulb. What I have here is the wiring loom, which is going to the front of the tractor. And you find the same colors back, blue and white and blue and black. And we know blue and white is the high beam and the other one is the dim light. So I hooked up a little light bulb to the high beam, so that should lit up as soon as I turn on my switch to the high beam position. So let me turn that. I need to lift it a bit. So that's position 1, that's dim light. Now this is position number 2, which is obviously now my high beam. So let me turn this down, and now I'm in the dim position. So if I move now my connector to the dim position, there we go, we got a connection again. So I know all this is working just fine. So the next thing is to connect all the warning lights and the gauges or the dials inside the dashboard. And for that we're going to connect all the green cables, which is the plus 12 volts coming from the switched position of the ignition key, towards one leg of the gauges, which is marked with plus, and with one leg to the light bulbs, the warning lights. It doesn't really matter to what side you do it. And then from the other side, we'll run it out back to the sensors that are on the tractor. So let's get on with this. Key switch done, fuse box done, main switch light done. So let us go down the wiring loom, and the first thing we hit now is the charge lamp, which is actually the light that will trigger the alternator. And there I have a yellow cable and a green one. And the green one, well, that's actually the one coming actually from the fuse box. That's the switched one, which depends on the position of the key switch once we position it to ignition. The next one down is actually a warning light for the high beam. I don't know if I'm going to put this in, I might actually. But then the next one is again a warning light for the oil pressure. Again a green one, plus 12 volts, and then a white one going actually to the sensor. And we can keep following that. The next one is actually the fuel gauge. And then the next one is the temperature gauge, which has a ground, and again the green connector. So we're going to hook all this up. And then finally we'll hook up the horn switch, which are 2 connections. And yeah, I don't have a side light, so I don't worry about that. So I can't use that one. And then we still have to do some extra work because we're still missing some extra connectors for the blinkers. And we're missing some connection for the vacuum or the empty hydraulic warning light, which is not on this wiring diagram. This is something we'll have to create ourselves. All right. So the first gauge is our fuel gauge, and we have a ground connector, and for that we can use a spade for that. We have a light bulb, so this is to eliminate the dial. But for that there's no cabling foreseen in the wiring loom, so we'll have to make that separate. And then we always have a plus 12 volts input, and we have the return or the lead going towards the actual sensor on the engine block or the fuel tank, in this case the float. If you want to know how these dials work, then please refer to my other video on how all these sensors and dials are working. I explained this in quite some depth. On the other side we have the temperature gauge. Now the temperature gauge is exactly the same setup. You have a plus 12 volts and you have another connector going back to the sensor, which is sitting in the thermostat housing. Again, you got the light for the dial itself, and there's no ground lug, but we connected to this nut here. But note that I have no spades here, so I can't really connect the wiring loom, and here is that wiring loom. I can't connect that up. So I made some conversion cables, and these are the conversion cables like you see. You can decide to cut off this connector if you want, and then put an eyelet on it. That's up to you. I decided not to cut anything off the existing wiring loom. And for the warning lights, I've done exactly the same thing. This is the hydraulics warning light, this is the oil warning light, and then at the end we have the charge light. I have made actually all little converter cables for that because this was with screws, and my wiring loom, as you have seen, is not with screws, but it's actually with spades. But doesn't matter, I created the spades over here, so I can use those and slide it in. Again, this is up to you on how you want to do this. So according to the wiring loom, the yellow one is my charge light. So I'm going to take the black cable and hook that up to the spade. There we go. And I will use my plus 12 volts equally to the charge light. So let us see if the charge light is working. This is the voltage coming in from my fuse box. That seems to be turned on. And I also have voltage going back to my alternator, and that is looking pretty good. So now actually that light bulb should lit up. So let's see, if we turn on the contact, the light should come on, and it does come on. Now let's see if we can crank up the engine. And that should go off as soon as we have a bit more RPMs. And that just worked fine. So let's continue with the rest of the dials. So we have done the charge lamp, so now we're going to go for the oil pressure warning light, which is a white and green cable. And here that is, the white and green cable. So this is going to go to the oil warning light. Again, we're going to apply the same methodology. We're going to apply the green plus 12 volts to the red wire, or the right jumper cable we made, and then the actual sensor will go to the second cable coming off the light bulb. And that's it. If you look on the wiring diagram, you won't find this connector here or this cable. This is coming out just after the light switch, but there is nothing there after the light switch. Here you go. There's nothing there with a single wire coming out. And then on the other hand, I have two more wires over here, which are the same color. The green one is the plus 12 volt, and the other one is, it's this cable right here. So what I'm going to do is I'm going to use this for my hydraulic warning light. Maybe that was a change on the wiring loom afterwards and they never documented it. That's what I suspect it is. So let's hook it up like that and mark it as such. Same method, plus 12 volts, we feed it to the light bulb, and then we will squeeze it in tight, and then the other cable, which is going to the sensor, which in this case is my vacuum sensor, and yeah, we'll have to wire that up to the back of the tractor still because we haven't done that part, but that's all right. And let me squeeze that in, and that is in. All right, we are done with that as well. So what I'm going to do now is put some tape up these connectors so they are held together. The next thing we're going to connect is the temperature gauge, and on that one we have a blue wire coming from the sensor in the thermostat housing. We have the green cable, which is going to provide the plus 12 volts to the gauge, and then the ground lug. If you want to know how these gauges are working, then check out my channel. I have a whole explanation on how they work. So let's hook it up, and then after that I will actually hook up the fuel gauge, and then we'll do a few checks. On the gauge you will find a marking, a plus 12 volts, and you will also find a T. The T is going towards the sensor. The plus 12 volts is actually where you need to feed the green cable to. So we know that the fuel gauge is using the colors, where are they? Blue and green. So the green one, I will feed it to the plus 12 volts, and then I will connect the cable, which is blue, towards the other connector. And again, I made these jumper cables, and that's where we go. There we go, that's connected. I still need to connect the ground lug, and for that I will actually remove this screw here and then put it underneath. And I hope we have a good ground once everything is connected up. And now I'm going to connect the last gauge, which is my fuel gauge. And as you can see, this is becoming a little bit of a clutter now. Let me move some out of the way. Alright. Okay, so we can see what we're doing. Again, it's the same methodology. T is for the sender, so this is going to the float. I'm going to hook that up, which is the green and black cable. And again, you need to look on your circuit diagram to find out the exact cables and colors, right? Here we go. And we're going to connect the plus 12 volts on the other side. And the ground lug, I'll do the same. Although we have a special connector here, I see. But it's probably all the same. And let me hook it up the same way as the other gauge. But I will also make a little connector between this spade here and the ground lug. And here is the little jumper cable that we kind of created. That will go on the ground connector, and I will also place it underneath here for the ground lug, so we certainly will have a good ground. There is nothing as bad as a poor connected ground. You get all kind of symptoms and problems which are hard to diagnose, so you better do it right from the start. There are a few things that we haven't connected yet because there's nothing in the wiring loom that I have for the dashboard, and that is the lights that illuminate the dials. I'm going to connect that up right now, and this is very simple. You connect the light bulb on each of those dials with a jumper cable back to the switch where you turn on the lights, and just connect it to the position of the dim lights, and then you have that in place. The other thing that I still need to hook up is the flasher unit, and you'll see that. And then finally we have still to create the wiring loom from the back of the tractor to the front with a special connector, because we have nothing of that. We only have the light system for the front of the tractor but nothing for the back. So there's still a bit of cabling to be done. So now let's first of all hook up these lights in the dials or the gauges, and then we can check a few things out, see if the oil pressure switch is working, see if the temperature gauge is working, see if the diesel fuel gauge is working or not. Now, I have to say I still have to change the gauge inside the tank because there's too much oil in the tank, so I'll have to suck it out first, because otherwise if I take out the gauge, the float, it's going to spoil all over the place. So that's something we still have to do. And then I will install the new float unit. But I'm going to show it to you with a loose float unit next to the dashboard so you can see how it's going to work. All right, so yeah, let's carry on again, I would say. So meanwhile, I have hooked up the light bulbs inside the gauges with this red cable. I daisy chained it between the two, and it runs all the way back to the light switch where it connects to the dim position. I also hooked up the high beam warning light, which is sitting here. I connected the ground, and then the white cable is going all the way back to the light switch and picks up the high beam voltage whenever that has been selected. What is left to do is to hook up the flash unit. We haven't done anything on the flash unit and the selector for the flash unit itself, the switch to indicate left or right. And we still have to bring in a wiring loom from the back of the tractor for the rear lights and the blinkers and the vacuum switch, which we already have kind of provisioned on this cable here. So let's see if things are working the way they are supposed to work. So first of all, I'm going to turn on the lights and see what happens without having the contact key on. So you can see the lights come on in the dials, which is good. The high beam light is off. I know I still have the wrong color in it. It should be blue. So but let me turn the knob one more stand. And now I actually have my high beam on. So that's good. And now the lights are off. So this seems to be working quite well. And now I'm going to turn the contact on, and we should see the charge light coming on and the oil pressure light on. The hydraulic vacuum or the empty hydraulic system is not going to work because I haven't hooked it up yet in the back of the tractor. And the horn should be working. So let's turn that on. We've got the charge light, we've got the oil pressure light, and we've got the gauges now starting to work. You can see the fuel gauge is now like 3/4 full, but that's because I have the fuel gauge laying loose. I have not used the one inside the fuel tank because I need to replace it. And of course the engine is cold. And I can actually use the horn. I'm just going to move the float around a little bit so you will see the gauge going back and down. So now we should be empty. And now we should be full. So now let's give it a try as it was a real start. That's good, oil pressure goes off. I still have the charge light on, but that's because it's running pretty slow. So now the charge light is off after I've given it some throttle. I'm going to let it sit now for a while and see when we come up to temperature. I know the fuel gauge is not correct. The float inside the tank is not 100%. I haven't changed that. I'm just going to let it sit now for a few minutes and see if it's going to warm up or not. So far, everything seems to be working just fine on the dashboard. So we are about ready to reinstall it onto the tractor. However, I still need to install the flasher unit and the switches for the flasher units, and then of course the rear cabling as I mentioned before. So let us have a look at the flasher unit on how that is working and on how we can connect it, because it is not part of the wiring loom. So what we have here is a traditional flash unit for 12 volts and 42 watts. So in other words, a current will flow through this unit and we will apply the plus 12 volt to the top connector here, and this is a 3 connector unit, and that's marked with an X, so that's the plus 12 volts, the power supply, and power will flow through the unit and then back out to the L connector, to the lamp basically. Of course in this case we will go into the switch will determine to which flash light it will go, but for the sake of testing we're just going to hook it up to a light bulb and then see how it works. The way this guy is working is very simple. When current flows through the unit, it's going to heat up the unit inside and the bimetal will start to deform and open up the contact. The current then stops the flow and of course the heat is then gone. And when the heat is gone, the contact will then close again and current starts to flow again and the cycle will repeat itself. This is how these old-fashioned flash units are working. If you're having a solid-state flash unit, it's quite different. But this one is a very simple forward device. So let us hook it up to the plus 12 volts and a light and then we'll see how that works. So I have cabled in partially the flasher unit. I took the plus 12 volts from my key switch with the red little wire and I use an additional position on my fuse box. This is the new position right here. And then I'm feeding it through the fuse back out on the top on the red cable right here, going back to the X connector on the flash unit. And now if I was to connect a light bulb to this connector here, the flash unit should work. So here is one of the rear lights we will install, and the indicator is right on the top, and I have the indicator connected to this little green cable here. If I now was to connect it to my flasher unit, you should see the indicator starting to flash. And this is how it's supposed to work. Now let me take it off. So now we need to connect the output of the flash unit to the indicator switch. And the indicator switch has a couple of connections. So you got to find out who is what. So you need first of all to find the central feed line. And this is that one, because I did buzz it out, and use your ohm meter to buzz it out. So if I buzz it out now, I have no connection whatsoever, because my indicator switch is set in the middle position, so no blinkers. Let me turn that over to A position, maybe to the left or to the right. So I turn that. Now I should have a contact between the middle one and the right one. You can hear beep. And nothing between the other side. If I move it to the other direction, then I should have it to the other contact. So let's measure again, and here it is, and nothing there. So I know this is my central connection going to my output of my flasher unit. So I need to make a cable for that. And then I have left and right for my indicators, which I will then connect. So let me make that little cable, and then we hook it up, and then we'll try the blinkers left and right and see if it works. I have connected the output of the flasher unit to the center position of the indicator switch, and the green one is my indicator for the left, and the yellow one is a cable for my indicator to the right. These are just 2 test cables for now, because I still will have to make the final cables to create that special wiring loom for the rear lights and the blinkers, as I mentioned before. So this is still something we have to build. So let's try this out. So I placed an indicator. My second indicator, which I wanted to place here, I don't have the bulb for it. Unfortunately, it came without the bulb, and this one came with a bulb. Pretty weird, but that's the way it is sometimes with parts. But this is supposed to be to go to the second indicator. And the yellow one, which is already connected, as you can see right here, is the indicator for the left. And this is just my ground. I know this should be black, but you need a ground, right? So I just use the red cable, which I shouldn't. It should be black. All right, so let me just turn the indicator now. Well, now you can see it is flashing. I can turn it off. Turn it the other direction, nothing happens, and it shouldn't. So remember, if I turn it towards that direction, nothing happens, and that should actually activate the green wire. So let me swap the cables. Let me move this aside, making no shorts, and hook up this guy. All right, the green one. So now if I turn it that direction, it should not flash. But if I turn it to the left, it should start to flash. And it does. So now I know that the flash unit and the flash selector, or the indicator selector, is working just fine. So we are basically done with the dashboard. Everything is cabled in, everything seems to work. We've tested all out. So now I need to install the wiring loom coming from the rear lights on the fenders on the tractor all the way through some tubing all the way to the front, where we'll need to install another big white plug. And I have the plugs, I showed you the plugs before. So I have to prepare all that cabling now, and then we'll also do some more connectors inside the dashboard that will then join that white connector plug for the rear wiring loom. Now I don't have a rear wiring loom at all, so I will make it myself. In order to do so, I'm using what we call trailer cable. And trailer cable is nothing really special. It is just a cable that has about 7 wires inside, and that's more than enough for this tractor. You can get them with more wires if you want, but for this tractor all I'm going to need is a blinker left, blinker right. I will have to have my vacuum switch or the empty switch for my hydraulic system, and I have to have the lights, and then I can still have braking lights if I had that one on this tractor, but I don't have it. And I could even have a fog light if I wanted to. So I'm not going to need all these wires, but I will need some.